champs, welcome back again to my channel, and today we are going to learn on the topic isomerism, which I think many of you have doubts and many of you have commented that you want me to do on this topic, that is isomerism. So here we go, and isomerism, it comes from the chapter carbon and its compounds, so it's very easy but also an important topic. So you should know how to what are the different structures of isomerism, or what is isomerism, and how to draw those isomers. That one we'll study in this topic. Okay, so here we go. So when I say isomerism, so isomerism, it's a phenomenon. Okay, first we should know what are isomers. So when I say isomers, so what is isomers? So when you have, so you must have seen different structures of isomerism. Okay, that the different structures of regarding various organic compounds in this chapter. So here you'll see certain structures which are where you will see the molecular formula is same but the structures are different. Okay, so those are called as isomers. So if the formula is same for two different organic compounds, if you see their formula is same, molecular formula is same, but when you draw the structures of those particular organic compounds, you will find it different. So those are called as isomers. Okay, so isomers are compounds with same molecular formula but different structural formula. These are called as, so those compounds are called as isomers, and the phenomenon is called as isomerism. Okay, different types of isomerism is there. Here you need to study only the structural isomers. Okay, under structural isomers you will study the chain and the position isomers. Okay, so here we have to study only these two under the structural isomers. So here we go. So when we say isomers, you just have to remember molecular formula is same but their structures are different. So those compounds are called as isomers. Okay, now if you have to know the isomers, how many isomers will be there for various alkanes. Now there is a formula especially for alkanes. Okay, so for alkanes, and that too up to carbon number, between carbon number 4 and 7. So this formula is applicable only for the those alkanes who is having either 4 carbon atoms, 5, 6 or 7. Okay, from 1 to 3 there are no isomers, there is only one structure, you will find one formula, one structure. But from 4, carbon number 4, that is from butane, so you can till from butane till carbon number 7. Okay, so that is heptane. Till heptane you can use the formula and find out how many isomers are there. The formula is this one. Okay, 2 to the power n minus 4 plus 1. Okay, so n stands for the total number of carbon atoms present in the compound. So if it is carbon butane, that means carbon is 4 carbon atoms are there, so you'll put n as 4. So what will be the formula? So 2 to the power 4 minus 4 and below plus 1. So how much will it be? So 4 minus 4 is 0, anything to the power 0 is 1, so 1 plus 1 equal to 2. Okay, so that means butane is having 2 isomers. Same way if I have to go for 5, that is pentane. So let's do, so for 5 what will you do? 2 to the power 5 minus 4 plus 1. So how many isomers will I get? So 5 minus 4 is 1, so 2 plus 1 equal to 3. That means pentane is having 3 isomers. Okay, so 3 isomers for pentane. Same way for hexane, what will you do? You put n equal to 6, so 2 to the power 6 minus 4 plus 1, that is 2 to the power 2 plus 1, so 2 square means 4, 4 plus 1 equal to 5. So hexane is having 5 isomers. Okay, so till heptane we can find it out. Okay, so till heptane you have this formula. After heptane, that is, if it is carbon number, if there is 8 carbons, then you will have 18. Okay, for heptane will have n, so till here you will use the same formula, 2 to the power n minus 4 plus 1. Now for octane, that is carbon 8 carbons are there, then you can use this formula, 2 to the power n minus 4. Instead of plus 1, you'll use 2. Okay, and if it is for nonane, okay, so that is 9. So 2 to the power n minus 4 plus 3. Okay, so for nonane or for carbon 9, if carbon's number of carbon is 9, you'll use this formula. Okay, and for the last one, that is decane, that is carbon 10. What you will do is you will add up also. For methane, there is only one structure, ethane only one, propane only one. Okay, we cannot use this formula. So so there is only one structure. So if I put 1 here and you add all of this till 35, till nonane, you will get 75. So decane is having 75 isomers. That's one way of remembering. So 75 is the isomers are possible for decane. And how did I get 75? If you count all as these three as 1 1 1, and remaining ones whatever is there, you add it till 35, you will get 75. So that's the isomer of number of isomers for decane. So till carbon 4, from butane to heptane, okay, carbon 7, you will use this formula. Okay, after that you have carbon 8. For carbon, number of carbon as 8, you'll use this formula, plus 2 instead of 1, you'll use 2, and 9 you'll use plus 3 instead of plus 1. That's so either you do you can remember this, or you can directly remember the possible number of isomers here. Okay, and remember, for methane, ethane, propane will have no isomers. There is only one structure. For methane, ethane, propane, you cannot draw more than one structure. Now why is it happening? Why we are getting only from butane you are having isomers? Because in order to have different structures, so there should be more than 3 carbon atoms for the rearrangement of the carbon atoms. Okay, if there is anything less than 3, the carbon atoms cannot arrange themselves, so there will be only one structure. You cannot have more than one structure if you are having less than 3 carbon atoms. Okay, that's the reason from butane onwards you will have, since butane is having more than 3, that is 4 carbon atoms, from there isomers are possible. And if you see through this formula also, you can find out the total number of isomers. Okay, so let's do the structure for butane. Okay, so butane means 2 3 4 carbon atoms. Okay, so let's draw the basic one, 1 2 3 4. Okay, so this is a straight chain structure. You draw the basic structure of butane. Okay, this is 4 carbon alkane, butane is alkane, so single bond, and remaining ones you put the hydrogen. Okay, so here put the hydrogens. So this is one isomer of butane. So butane, as per the formula, you have 2 isomers, right? So this is one formula. Another is, what will you do? Out of 4 carbon atoms, you put 3 in the straight chain. Okay, so this is straight chain, so parent chain. So 3 here you put, 1 you put it here. Okay, so this is, if you put here and here, it will be wrong, because it will be again it becomes the same one parent chain only. Okay, so you'll put it in the middle. So this, and remaining ones you put the hydrogen. So for this carbon you have 1 bond already gone, so you have 3, remaining 3 you put the hydrogen. Okay, for this carbon 3, again 3 hydrogen, and for this carbon already 3 bonds are done, so 1 is left out, so you put the hydrogen. For this 3 hydrogens. Okay, so this is the second isomer of butane. So one is this, one is the branched, one is the straight chain structure. Okay, whenever you see a straight chain structure, you will put this alphabet N, small letter N. So N dash butane. Okay, this structure is named as N dash butane. And when you say this structure, it is called isobutane. Okay, this is the common name, isobutane. We can write this, or if you want to write as per the IPC name, standard position 1, then what will you do? Now see here, this is the parent chain, this is the alkyl group, right? CH3, that is alkyl, that is methyl group. So you have to number it. Okay, so you can start from here or you can start from here. So this is first carbon, this is second, this is third. So since it is an alkyl group, so it will be a prefix. We have already done nomenclature in the earlier video, so you can have a look once again if you are having doubts how to name a compound. So here second root word is for 3 carbon, so prop, single bond, so propane. And since alkyl group is there, that is methyl group will be a prefix, so it will come before the root word. So methyl, okay, this will be small letter. And second position methyl group is there, so you have to name the position. So 2-methyl propane. So this is the IPC name for this isobutane. Okay, you can name this or you can name this, both are correct. This is N-butane, this is isobutane. This is N-butane means normal butane structure. IPC name you can write butane. Okay, so if you're writing N-butane, you have to write isobutane. Okay, that, and butane is the most common isomers that are being asked in the exam, board exam. So butane you have to learn it properly, and please draw the structures in detail. Okay, don't put the condensed structure like this. Okay, don't do this, because examiners always or they are happy when you draw the detailed structure. Okay, so go for this, not this one. So this is butane. Let's do pentane. Okay, pentane also same. The basic structure first you draw. So 5 carbon, all are single bond because it is an alkane. 1 2 3 4 5. Okay, and remaining we put the hydrogen. Okay, so this one all hydrogens here. So this is the first isomer of pentane. Pentane we are having, we'll get 3 isomers, right? As per the formula you see 2 to the power 5 carbons, so 5 minus 4 plus 1, so 2 plus 1 3. Okay, so 3 isomers we have to draw. This is the first one, so straight chain, so N dash pentane. Okay, second one, 1 alkyl group, 1 carbon you'll put it just like butane, you'll put it in the second carbon. Okay, 1 2 3 4 carbon, so 1 you can put it here. Okay, that's how you draw. So this is just you put the hydrogens here. Okay, here you put the hydrogen for this carbon. Okay, this is your isopentane. Okay, this structure is isopentane, or you can write 2-methyl. Your numbering will start from this side because this is in second position, the alkyl group is there. If I start from here, it is 3. So in third position it will be there, which is more. So we will always have the lowest priority one. So in second carbon from this side, if I count, it is in the second group or in the second carbon. So we'll start from right side. Okay, so 2-methyl, then root word will be 4 carbons are there. So but, methane, 4 are there. So but, single bond, butane, 2-methyl butane, 1 2 3 4. Okay, 4 means but, single bond, so ANE, and 1 methyl group is at the second carbon, so 2-methyl butane. And the last one, so what will you do? You put 3 carbon here, 1 carbon at the top in the middle, and 1 carbon at the below this same middle carbon. Okay, and rest you put the hydrogens here. Now for middle carbon all the bonds are filled up, so no hydrogens is required for this carbon, and here 3 more hydrogen. Okay, so this is the third isomer of pentane. We call it as neopentane. Okay, N-pentane, isopentane, this is neopentane. Okay, and if you have to write as numbering, if you do position, so first, second. Okay, so here it will be in second position. Here also alkyl group is there, methyl group is there, here also methyl group. Okay, so that means 2 methyl groups are there, so dimethyl. And in second position 2 methyl groups, so we will write 2 comma 2 dash di 2 methyl groups, so dimethyl Then this is the root word, so 3 carbons are there. Propene, single bond, so propene. Okay, for your knowledge I have given in details this one. Okay, numbering you just have to write iso, neo and n. Okay, for your exam, no need to remember all this. This is for your reference. I have given how to name this compound. So so you better write this, no need to write this. Okay, so either butane or pentane generally will come for your exam. Okay, they don't give you hexane and all. Yes, they might tell you draw any two structures of pentane or draw any two structures of hexane. So same way you can draw. One you can draw like straight one you can draw like this. Okay, and one you can draw like this also. Remaining ones you put it like that. Okay, so either way, any three, whichever is you feel is you can do it, so that one you do it. Okay, so these are the three isomers of pentane. Now hexane, try the structures of hexane. For hexane you do it by your own. Use the formula. So hexane will have 2 to the power, hexane means 6, 6 minus 4 plus 1, so 2 square plus 1, so 4 plus 1, so there will be total of 5 isomers of hexane. Okay, so find it out, write the possible structures of hexane. Write this one. Now there is also question on what are the possible isomers of this compound. Okay, C3H6O. So you see here, so even so H6O. Okay, so one oxygen is also there. So when which are the functional group that has oxygen and hydrogen. Okay, so here you can see it can either be aldehyde or it can be a ketone. Okay, 2 oxygen, it would have been carboxylic acid or ester, but since only 1 oxygen is there, that means either it can be aldehyde group or it can be a ketone group. Okay, that is present there. So these are the 2 isomers of this compound. So what will you do? One you draw as aldehyde. Okay, so 3 carbons are there. First you draw the 3 carbons. Okay, then H1 for aldehyde you take 1 hydrogen here. So 1 oxygen, this is aldehyde group, CHO, right? And remaining ones you put the hydrogen. Now you can, if you count how many hydrogens are there, 1 2 3 4 5 6, you see here 6 hydrogen, 3 carbons, 1 2 3, 1 oxygen is there, so O. Okay, so this is one isomer of this compound. Another you make it as ketone. Ketone means it will be in the middle, 3 carbons, so 1 2 3, then put the oxygen in between. This is ketone. That's how you write a ketone. Then rest you put the hydrogens. Okay, here also 3 hydrogen. What about between one? 1 2 3 4, already 4 bonds gone, so no hydrogen for this compound. Now you count the total number of hydrogens, 1 2 3 4 5 6, same 6 hydrogens, 1 oxygen and 3 carbons, right? So we can call them as isomers, yes or no? Because why? Because their structural formulas are different, but the molecular formula is same. So they are having both are having 3 carbon atoms, 6 hydrogen and oxygen is also there, but their structures are different, right? So they are also isomers for this compound. So anything which has the same molecular formula but different structures, so those compounds we have already studied, they are called as isomers. So these two are isomers of this compound which has the molecular formula C3H6O. Okay, so this question also comes, so this is also important one. Okay, so how to name it? Now 3 carbons, right? 3 means root word will be prop, single bond, AN. Now since aldehyde group is there, so E will not be there, so Al, propanol. Okay, or 1 dash. So in first carbon aldehyde group is there, so 1 dash propanol. And what about this one? This is a ketone. This ketone group is there, so 3 again prop, single bond, AN. Now ketone, that means ONE will be there at the end, so propanol or 1 dash propanol. Okay, so this is also correct, or propanol, you can write propanol. Okay, so that write the name along with the structure. When you're drawing any chemical compound or carbon compound, you should always write the name of the particular compound. Okay, so these two are also isomers. I hope now I'm clear what are isomers. Okay, now let's do some certain questions. Are structural isomers possible for bromopentane? So can you draw, so bromopentane, right? So bromopentane, what is the formula? So pentane means 5 carbon, 1 2 3 4 5. Okay, so this is bromopentane. So can you draw very structural isomers for this compound? Yes or no? If yes, how you have to show. Okay, so yes, we can draw the structures of bromopentane. Okay, so one is a straight chain you can draw. 1 2 3 4 5. Put the bromine there, here or here, it's the same. Rest all you put hydrogens. Okay, that's how you draw a bromopentane. One, this is one isomer of bromopentane. Okay, now you can draw the another one. You put the bromine in a different carbon. 1 2 3 4 5. Okay, so here you put the bromine, this is another one. Rest all you put the hydrogens. Okay, here you'll put the hydrogens. This is one isomer. Another one, what you can do is you can put the bromine 1 2 3 4 5. So here you can put the bromine. Okay, so there are 3 isomers for bromopentane. You just shift the bromine in one position. So first is at the end, second one you can put in the second carbon, either from this side or this side, both are correct. And the third one you put it in the middle carbon. Okay, that is the third carbon. Either from here you can count, this is 3, from here also there's a middle carbon, right? And here you put the hydrogen. This all you put the hydrogens. Okay, so these are the 3 possible structural isomers of bromopentane. Okay, so this one is straight, so this is bromopentane. So 1 dash bromopentane, or bromopentane means in the first position bromine is there. This one is in the second carbon, so you start from here, wherever the functional group is there, from that side you'll start. So this is first, this is second. So 2 dash bromopentane. Okay, and this one is in the third carbon, so 3 dash bromopentane. Okay, so these are the 3 isomers of bromopentane. Okay, now why, same this one already I have discussed, why does isomerism occur only in compounds having at least 4 carbon atoms? We have already said because it be less than 4 there will be no structural arrangement. Okay, so isomerism starts from 4 carbon atoms because only from carbon 4 onwards carbon atoms can be arranged in more than one way. Either it can be straight chain, okay, or it can be branched. This is branching one, right? So it can either be straight or branched. It can be done only when the carbon number of carbon atoms is from 4, okay, not less than 4. Well, so it has to be at least 4 carbon atoms. Okay, isomers, now this is MCQ. Isomers are compounds that have different molecular formula, same molecular structural formula, have the same molecular formula but different structural formula, or have different molecular. So it will be option C, because isomers have same formula, molecular formula, but different structural formula. Next one, which of the following pairs represent isomers? Okay, you see isomers, for isomers the formula has to be same, right? So you see here C2, here C3, so it cannot be. Now here 4, here 4, 10, 10. So this can be an isomer. Let's see the others. Here 1, this, here it is 2, it cannot be. Here 3, here 4, it cannot be. So B is the correct option. Both the molecular formula has to be same. Butane has how many isomers? We have already done. So butane has 2 isomers. Which is an isomer of butane? So we have, so out of this, which one is a isomer? So you know the structure of the isomers of butane. So this will be your methyl group is there. So 2 dash methyl propane. Isomers show differences in physical, chemical, both A and B, or none of these. So isomers always show difference in physical properties, okay, not in chemical properties. Can methane show isomerism, and why? We know methane we can also, because number of carbon in methane is only 1. So for 1 carbon there is no arrangement of carbon atoms. We need minimum of 4 carbon atoms. So same question, but as an example they have asked. differentiate between chain and position isomerism. Okay, so as I said, isomers means this is chain. Okay, and if the position like bromopentane we have done, so bromine position is same, functional groups if you change the position, that comes under positional isomerism. Okay, so different chain isomerisms where different carbon chains are there, for example n-butane, isobutane. Okay, position isomerism is same chain but different position of functional group, as in this case I've said, or if you put butane 1 dash all or butane 1 dash or 2 dash all. So that means if you put a functional, any functional group, if you're putting, this is butanol, right, one position, and two position will be in second position if you put the OH group. So that is your butane dash 2 dash 1. So if any functional group is there and their positions are changed, then it is called as positional isomerism. And chain isomerism is difference in the chains. Okay, it can be like this or it can be like this. Okay, so that is where there is different carbon chains, so that will come under chain isomerism. Okay, explain why isomers have different physical properties though they have the same molecular formula. Okay, we all know that isomers have molecular formula, then why they are having different physical properties? So this is the answer, because their structures will differ, right? We have seen their structural arrangement of atoms are different, so that as a reason what happens, their physical properties such as boiling point, melting point, density, everything will, there will be a difference. Okay, straight chain molecules will pack differently from the branch one. So the n-butane, suppose, okay, straight chains, they will have different properties than the branch one. Even that they also have different properties, physical properties. Why? Because the arrangement of the atoms are different in both the cases. Okay, so that is, this is another question that is being asked, so you should know physical properties are different, chemical properties is same, molecular formula is also same, but the physical properties like melting point, boiling point, density, all the physical properties, there will be difference. Okay, so that's all for today. So I hope now you are comfortable regarding isomers. So practice the structures, remember the names, see the properties, see what is same, what is different. Okay, types, you check it out. So that's all for today. Anything else you want to know, please feel free to comment on the comment section. Okay, and enjoy learning, keep learning, and do subscribe my channel, like my channel if you really like my videos, and thank you so much.